Now that we have learned about the best path selection algorithm, let's see how we can use the algorithm and understand how to troubleshoot the best path selection process. The important factor before we get into troubleshooting is to remember few points wherein when the best path selection process eliminates the paths which are ineligible for best path. The first criteria is not synchronized. If the sync or synchronization command is configured and the route is not present in your IGP table, that path is not selected for the best path selection algorithm. Inaccessible next hop. If the IGP does not have a route or the next hop to the path received becomes inaccessible or unreachable, then that path becomes invalid for the best path selection algorithm. Received only paths. Based on the path that is filtered out using the inbound policy will only be considered as a received only path. It will not be made part of the best path selection algorithm. Let's now have a look at this topology and we can walk through a demonstration to understand how the best path selection algorithm works. AS100 is advertising prefixes 100.1.1.0/24 and 100.1.2.0/24. It's having eBGP pairing with AS200 and AS300. AS200 is then having an eBGP connection with router 2 and AS300 is having an eBGP connection with router 3. And if you can notice, both of them are advertising the same prefix. As I mentioned before, if the router receives the path first, it will install that path and make that path as the best path. Unless it receives another path for the same prefix, it will not change the best path for that router. Based on another path that has been received, only then the best path algorithm runs and the best path changes based on the selection process. Let's now have a look at the routers to see how it is influencing the best path. Let's have a look at the different routers in the path from AS100 to router 1 and see how the best path selection algorithm is getting influenced. Let's verify the running configuration for BGP on AS100 router. There are two network statements, 100.1.1.0/24 and 100.1.2.0/24, which are being advertised towards the neighbor 10.1.102.2 and 10.1.103.2. These are the neighbors for AS200 and AS300. Let's now see what AS100 is advertising towards the neighbor in AS200 and AS300. We can use the command show BGP IPv4 unicast neighbors 10.1.102.2 advertised routes. And you can notice that it is advertising the prefix 100.1.1.0/24 and 100.1.2.0/24. We'll run through the prefix 192.168.1.1/32 later on when we are going towards the path advertised via router 1 towards AS100. But we can clearly see that these two prefixes are being advertised towards AS200. We can run the similar command towards AS300 and see if those prefixes are being advertised there as well. And we can see that both those prefixes are advertised. When we go on router AS200, we can look at the BGP table to see if the prefix has been received by AS200 or not. Show BGP IPv4 unicast. And we can see that the prefix is received from the neighbor 10.1.102.1, which is configured on AS100 router. We can run the similar command on AS300. Let's now jump to router 2 and router 3 to look at the BGP prefixes. On router 2, we can verify the path received from AS200. And we can see that the path 100.1.1.0/24 is received from the next hop 172.16.22.1. This is the IP configured on AS200 router on the interface connecting towards router 2. We are receiving both the paths. We can verify the same stuff on both router 2 and router 3. Before we move on to router 3, let's look at the prefixes learned via both router 2 and router 3 on router 1. The router 1 is an IOSXR router, so it has more flexible commands. We'll have a look at them one by one. Let's first verify the BGP table for the prefixes 100.1.1.0 and 100.1.2.0/24. We can see that the prefixes are being learned via two neighbors, 192.168.2.2 and 192.168.3.3. The prefix 100.1.1.0/24 and 100.1.2.0/24, we can notice that the best path is via the router 2, but we do not know why is that. We can verify why the router selected the path via router 2 as the best path. We can run the command show BGP IPv4 unicast, the prefix 100.1.1.0/24 and best path compare. This command not only compares both the paths but also tells you the reason why the path was not selected as the best path. Now if you look at the command output, we can see that the path received via 192.168.2.2 was selected as the best, whereas the path received via 192.168.3.3 was not made the best path. But here's the reason. The higher router ID than best path, and the path number is 1. So the best path is selected is the path number 1, and the router ID of the second path, which is 192.168.3.3, is higher than 192.168.2.2. Remember, from the best path selection algorithm, the lowest BGP router ID wins. Since all those attributes which are before that are same, the router ID is the tiebreaker criteria. And remember, we haven't used any attributes in the configuration yet. Let's now move on to router 3. On router 3, we can now see that show BGP IPv4 unicast command to look at the BGP table, and we can now see the best path is 100.1.1.0/24. The best path is via 172.168.33.1. Remember, before the lowest router ID, there's a criteria for eBGP preferred over iBGP path. The iBGP path is learned via this next hop, 192.168.2.2. But the eBGP path is learned via 172.168.33.1. That's the reason why 100.1.1.0/24 and 2.0/24 is selected as the best path via the eBGP peer. Let's now try to influence the best path selection algorithm, and let's see. We had a topology. We advertised the prefixes 100.1.1.0/24 and 2.0/24 from both AS200 and AS300. Let's now try to influence the best path using AS-path prepend. We are prepending AS300 when the prefix is advertised out via AS300. And we will prepend the prefix 100.1.2.0/24 with AS number 200 when advertising via AS200. Let's get back to the router. We go on to router 200, AS200, and we configure an IP prefix list with the name AS prepend. For the prefix, we are permitting the prefix 100.1.2.0/24. And now we set the AS-path prepend. We created a prefix list. We'll now match that prefix list as part of the route map, and we'll then set the AS-path prepend. We configure our route map AS-path prepend permit 10 match IP address prefix list AS-prepend. And we set AS-path prepend and the AS number. The AS number from here will be 200. And remember, we are only doing it for the prefix 100.1.2.0/24. Since we are doing that, we need to go back and configure the statement route map. We just copy it from here and say permit 20. And and we should be good. So now, since we have configured the prefix list, we have configured the route map, the next step is to configure this route map in the outbound direction of the neighbor. So we have show run pipe section router BGP. So we can configure this route map for this neighbor 172.168.22.2. We go into the config mode, router BGP 200, address family IPv4 unicast, neighbor 172.168.22.2, route map, the name of the route map, and we set the direction, outbound direction, and that's it. So we do the same thing on AS300 router. We go into the config mode. We first configure the prefix list, IP prefix list AS-prepend permit 100.1.1.0/24. We're good. And we now configure the route map. So route map AS path prepend permit 10. Match IP address prefix list AS prepend. Ensure that you're configuring the correct prefix list name. If you configure, or due to a typo mistake, you misconfigure the prefix list name, the route map will not function properly. Once we have configured the match criteria, we now use the set statement. Set AS path prepend with the AS number 300. Since we are doing it only for this prefix, we will now go ahead and configure permit 20. Route map AS path prepend permit 20. So this will allow us to not make any changes and advertise successfully all the rest of the prefixes apart from this particular prefix. For this particular prefix configured in the prefix list, it will advertise it, but it will set an action to prepend an AS path of 300. So we now go onto the router BGP configuration, router BGP 300. We go under the address family IPv4 unicast. We configure the command neighbor 172.16.33.2 route map AS path prepend in the outbound direction. And we are done. So now we go back on router 2. So remember, on the router 2 side, we went ahead and configured the route map to prepend AS path for the prefix 100.1.2.0/24. So on router 2, we can see now what do we have in the BGP table. So if you notice the BGP table, we have the prefix 100.1.2.0/24 and has a prefix with the path 200, 200, 100 internal. And notice that this path is not selected as the best path. And the reason is we have another path which is learned via smaller AS path, which is via 300 and 100. So we are not allowing the path received via AS200 router to be influenced as the best path. But we are still having 100.1.1.0/24 as the best path learned via the AS200 router. Similarly, on AS300, if we look again at the BGP table, we'll see the same behavior. We do not have the prefix 100.1.1.0/24 as best path via AS300 because it has the longer AS path list. The best path is selected via 192.168.2.2. Now, if we jump on to router 1, we can look at the BGP table, show BGP IPv4 unicast, and we can see only single paths received for the prefix 100.1.1.0/24 via router 2 and 100.1.2.0/24 via router 3. This way, we are influencing the traffic that the traffic towards the destination in subnet 100.1.2.0/24 will take the path via router 3 from AS65000, and for the subnet 100.1.1.0/24 will take the path via router 2 in AS65000. We now have another prefix 192.168.1.1/32. This prefix is being advertised as part of the router 1 loopback address. We have the BGP configuration and we have a network statement for this prefix. We now look at AS100 to see how that prefix is being best learned. And we can see that the prefix 192.168.1.1/32 is being learned via both 10.1.103.2 and 10.1.102.2. But one of them is selected as the best path. And it runs through the same best path algorithm to decide upon which prefix or the path from which neighbor will be selected as the best path.